Hello, hello, hello. Today we're going to solve for linear equations except using formulas. Now this is especially useful in physics. When you're going to do your first physics classes, you're going to rearrange formulas in order to find solutions. So let's take a look at this. Basically what they're doing is instead of having numbers like you had before, so we're going to look at example 34. This is 74. This is just an explanation, so let's do this. So we have here, hold on a sec, 3x equals 12. And here we have wx equals z. Now I want to make a remark here on what they're doing. Is here it's a number 3 times x, and we're comfortable with that. It makes 3x, right? So what that is really 3 times x equals 12. Now here what they're really saying is w times x equals wx. You see how both sides it's the exact same thing. Instead of it being numbers, they're variables. Now it could be apples, oranges, could be cars, it could be planets, but it doesn't matter. Those x's and y's represent a thing, and the number next to it represents a number of things, or it can just be another thing. So for example, 3 times x equals 3x. Y times x equals yx. Okay? It holds true. So if y equals 3, it would be 3x. But in this case, we don't know what y is. So we're just saying wx. That may be hard to understand, but anyways, bear with me. So I'm going to get my pencil out. All right, hold on. Equals z here. Here they put the letter z. That's another variable. And what we're really trying to do is especially in physics, you're going to want to solve for a number. So for example, it's going to be speed times time equals distance. So for example, it's going to be speed times time equals distance. You see how that looks like this problem? So it's going to be st equals d, or if you remove time from one side and add it over, they're going to speed equals distance over time. You see how we did that? So the first physics problem was the distance, all right? Distance equals speed times time. And here it is speed equals distance over time. It kind of makes sense, doesn't it? Take the total distance divided by the time. Let's say you did 100 kilometers and you did it in an hour. Well, your speed was 100 kilometers an hour. So moving along with example 75. Whoops, that's all. What's going on here? There's a little bit of latency here. Okay, example number 75. We have here m plus n equals p. All right, so once again, treat these all as variables. And what did you do previously with variables? What did they want us to do? They want solving for n, treat all other variables like numbers. Well, okay, so there you go. So we're solving for n. So we're going to subtract m from here and subtract m here. And we're going to have, well, I think it's pretty obvious, n equals p minus m, right? So that's the way that works. Let's go for number 7. That one was pretty easy. Oh, number 76, a little bit harder. Anytime you see something in brackets, algebraically, you can treat it as if it were a number. So a multiplied by x minus y equals b. We can't solve here. However, if we want to solve for a, what we're going to do is, so let's look at it differently. Let's say this thing were c, right? So it would be a times c instead of a times open brackets x minus y close brackets. Let's just call that thing in brackets c. So what would we do to isolate a? We would divide both sides by c, right? And we get a equals b over c, right? Do we agree? Because anything divided by the exact same thing is equal to 1, and 1 times a equals a. So that's the way I would do it. Now, here what they're trying to tell you is you can do a x minus y equals b, you can divide the multiplication of these two things by this thing. And a equals b over x minus y. That's your solution. Pretty awesome. We don't care what's inside x minus y in this point. We just want to solve for a. And we do that by treating these letters or these bracketed letters as individual items, as if they were numbers. Okay, so having that done, number 76, they say here, solve for a, treat like a didn't I just do that? Yes, I just did. Okay. Did I just do that? Yes, I just did. Okay, number 77 then. Hold on, let me write it down there so I don't get all screwed up. 77. Solve for x. Solving for x, we need to distribute. Okay, so, okay, I see what they want us to do. All right. So, okay, let's go here. A times x minus y equals b. Solve for x. Now, x is in the brackets. So how do you get what's in the brackets? Well, you multiply as you did in other lessons. You're going to multiply a times x, and you're going to multiply a times y. So that would be a times x equals ax. A times negative y here. So a times negative y equals minus a y. Oh, wait, sorry. Let me start that out. I screwed up. Ax. A times negative y equals negative ay equals b. You got that? That looks pretty good, right? That's what that gives you. So what do they want us to solve by? They want us to solve by... for x, right? Is that what they want? Solving for x. So I guess what we're going to have to do is multiply both sides by... How am I going to do this? Okay, so what I'll do is I'll shove this minus ay on the other side. So I'll do ax equals ay, because I did plus ay here, plus ay there. Ay plus this b right here. Okay, and then I'm going to divide both sides by a. And I will get x equals ay plus b over a. Is that the answer? Yes, it is. All right, that's good. That's good. So you see what happened there? Now, I know when you're going to be doing these problems, it looks like you're going nowhere fast. Saying, who gives a shit if I do these things? Well, it doesn't give a shit. Like, nobody gives a shit, right, if you do these things. However, if you do take first of all, it's going to help you in your algebra skills, if nothing else. Number two, what it's going to do is it's going to help you understand faster your physics problems, because I find in physics you do a lot of this algebraic manipulation, especially with trigonometry and all these things. You do all these manipulations, and you're gonna. That's what they call the teachers algebraic manipulation. That's what they always say. You're gonna have to do algebraic manipulations, and this is what this is used for. So we'll move on to example 78. What does 78 say? Y equals mx plus b. Oh, okay. Well, that's an important one. Okay, so hold on. Let me just get my pencil. This stupid Wacom pencil is not very handy. Hold on. Y equals mx plus b. They say solve for m. You're going to learn later that this is the point slope form. But anyways, it doesn't really matter. For now, we're just going to treat it as a regular old formula, which has 1, 2, 3, 4 types of variables. And now they want us to solve for m. I'll put a little solve here. All right. So what I'm going to do is I'm going to stick that b on the other side. So y plus b equals mx, right? So what I did was, not y plus b, y minus b. Screwed that one up. I'll do it long form. Minus b here, minus b there. So it's y minus b equals mx, right? Because b minus b equals 0. So I got to get rid of this x. So I'm going to divide by x, right? And here I'm going to divide by x. So m equals y minus b over x. Is that the answer? Yes, it is. Okie dokie. Moving along to example 79. What is 79? Next example is also a two-step equation. It is a problem we started with at the beginning of the lesson. So, okay, this was for the geometric formula for the area of, I think, a slanted cone or something like that. Okay, so they say here, solving for S, focus on what is added to the term with S. So they want us to, okay, so let's just write this down, all right? Oh, God, hold on. Area equals pi r squared plus pi r s. And they say here, solving for S, focus on what is added to the term S. Okay. So I guess what they're trying to tell us, these are the tricky things that they're going to do with us. All right. There are very, very tricky people here that do this. So what we're going to do is we're looking for this thing. So we want to get rid, when we're looking for something, we want to get rid of everything we can on the other side. So here, if I subtract pi r squared, and here I subtract pi r squared, what I can do is I can do a minus pi r squared equals pi rs. And what I'm going to do is I'm going to divide by pi r both sides, right? This will cancel. How does that look? Now, why aren't we dividing these pi r's, right? Why am I not getting rid of these pi r's to remove like the fraction? Because a minus pi r squared is not pi r squared. It has to be standing on its own. It has to be in a multiplication sequence like this. This is an addition, subtraction, and then multiplication sequence. You cannot do the dividing over. Is that the right answer, by the way? Yes, it is. All right, good. So let's do this again. Example 8. I know I'm problem 80. H equals 2m over n. Solve for m. So just not to get confused, this is a h and this is not a h, it's an n. We are solving for m as in mommy. All right, let's put this m here all nice. So what we're going to do here is we're going to multiply both sides by n. Why would I multiply both sides by n? Whoops, by n. Well, if you remember your cross multiplication, you can eliminate this because this is really n over 1. You can eliminate these two, right? Because n divided by n equals 1. And now you're left with 2m over 1 times 1 over 1. Well, 2m times 1 equals 2m. 1 times 1 equals 1. 2m over anything over 1 is whatever you had to begin with. So 2m divided by 1 equals 2m. So that equals 2m. Here, h times n equals hn. Now, to isolate the m, we divide both sides by 2. And I get h over n over 2 equals, cancel that, m. We have solved the problem. We have solved for m. I don't know why I always get sweaty when I do math. It sucks. All right, so now we have a, b plus c, b. That's nice. There's they have a common denominator equals c. Solve for a. All right, so what they're suggesting here we do is we get rid of the fraction. Actually, that's an e. Sorry about that. This mf here is an e. Sorry. So what they're saying is, now this is a good trick here. This is a very sexy trick. What you can do in algebra is put brackets wherever the heck you want. Example, you can decide, I'm putting brackets here. All right? That's nice. That's nice. And I'm putting brackets here. And you might say, well, I'm going to get rid of these b's. How do you get rid of these b's? Well, you multiply both sides by b. And whenever you multiply a variable by something inside a brackets divided by an addition or subtraction, you perform the multiplication to each single one. All right? So let's do this. So b times a over b. Well, I cross out these guys, and I'm left with a. Plus b times c over b. Well, I cross out these guys, and I'm left with c equals e times b. So, but there's another way of doing it. You can do a over b plus c over b. Now, for the ones who are freaking awesome, you may have noticed that there was exactly the same denominators. Therefore, we can do a plus c over b. And then we just cancel this out, and we're left with a plus c equals e over b. What are we solving for? We're solving for a. So we're going to subtract c on both sides, and we're left with a equals e b minus c. Is that the answer? Yes, it is. All right, number 82 now. 82. Is there a lot more? Okay, there's only 2 more left. 82. All right. So it says here a equals large A, that's usually an area, 2 minus b. Solve for b. It says use lowest common denominator 2 minus b as a group. Okay, what are they saying here? What does that mean? Whenever you're doing algebra, one of the key tasks of algebra is to get rid of the fractions as much as possible. All right? Especially when the thing that you're looking for is stuck in the denominator. So what we're going to do is, as I said before, you can put brackets around anything you want. There, I just did it. I just did it. Look, I can put brackets around this thing if I want. Look, I can put brackets around this thing. You can do that for anything, and that becomes an entity. That's a super difficult concept, but a cool trick. It's really awesome. That's mathematics is pretty strong. Algebra was started by I think it was started by a Persian. I believe it was a Persian mathematician who started algebra, and that's pretty awesome. So take a look at this now. So now my denominator is not just only 2 minus b. It's this bracket thing. So what I can do is I can make another bracket. Boom, I just made another one. You can put brackets as much as you want. And I will multiply this expression by minus 2 over b. And I will multiply this side 2 minus b, sorry. So take a look at this. I can cancel this, right? I can cancel this. That is awesome. So now I'm left with a. Did you see what I just did there? And here I'm 2 minus b multiplied by a. Whoops, I put a bracket there just because I'm going bracket crazy. Now I'm trying to solve for b. That's what I'm trying to do. So what I'm going to do is I'm going to solve for this, right? So it's going to be this times this and this times this. So it's going to be 2a minus ba. All right? We're looking good. That equals a. Now, how are we going to do this? Well, we can subtract 2. We're solving for b, so we can subtract 2a on both sides. So now I'm left with minus ba equals a minus 2a. Big A minus 2a. It's not the same, huh? When you see a capital, it's something else. So then I'm solving for... Am I tripping? Am I doing this right? No, I'm doing this wrong. I'm solving for b. Yes, I'm solving for b. Okay, I'm doing this right. Okay, so now what I'm going to do, I need to solve for b, right? So I need to get rid of that negative, and I need to get rid of that a. So I'm going to divide by negative a. Does that make sense to you? So that cancels. Over minus a. That should be the answer. Yes, it is the answer. Very good, very good, very good. What do they do in the book? Interesting. Did it a little bit differently. That's okay. But you get the point. All right. 83 now. A equals A over 2 minus B. We're solving for B here. Once again, brackets here. And hey, look, we made even more brackets. So this whole thing, we're going to multiply by 2 minus B, right? And we're going to multiply this thing by 2 minus B, A. So let's do this. Here we cancel. So we're left with 2 minus B, A. Okay, so what do we do first? Well, I would divide both sides by A, and then I'd be left with 2 minus B equals A over little a. Remember, A's are different in algebra. If they're capital or they're lowercase, it's a different letter. And then I just got to get rid of the 2, right? So I'm going to stick that 2 on the other side. So it's going to become A over little a minus, actually plus, no, minus 2. Because here I have to do minus 2. And I'm left with minus B here. So minus B equals A. So I want to get rid of this bloody negative number, right? So what I'm going to do is I'm going to multiply both sides by -1. All right, so let's do that. -1 times -b, so that's -1 times -b. 2 negatives in a multiplication make a positive, so I'm left with b. Here, -1 times this, you just add a negative, so negative large A over little a. And then -1 times -2 equals +2. Is that the answer? Yes, it is. All right. So now, next video, we are doing the formulas. All right, so hang on to your hats and don't get discouraged. And by the time you're done the classwork, the work that was assigned at home, plus doing my awesome exercise, you're going to know everything.